Hello, class. To continue the lectures on section 2.2, this one should be finished in this recording, hopefully. We will continue on basically displaying data and just a few calculations. So just to remind you, we were talking about histograms, which are statistical versions of bar charts where there's a width of each class and the frequency or relative frequency generates the height. And so in the last lecture, I went through a couple calculations with regards to that. And I just want to put up some special cases. And the first one is what we call this open-ended case. And I alluded to the fact where sometimes each one of the classes can't be exactly the same width. And you can see here with regards to last category of 85 or older, that means that the width could be bigger than 10, right? If somebody's 100, that would be a width of 15. And so typically, as I said before, in a grading system, the failing grade is a bigger width than all the other grades, which are typically the same width, typically 10 with regards to the 90, 100 is an A, and so on and so forth. Discrete data could be set up as a histogram or, fancy version of the bar chart as well, and you would do it exactly the same way. Instead of having a width for your category, you just have that single number or single category indicating that. And here's an example of a number of children where, 1,000 adult women were asked. And so to finish this one up, again, just to show you a couple other ways to think about it in a picture or display or graphical sense, the idea of data. So we're going to talk about this in really great detail when we start getting to specific distributions, but there are some technical math terms just to kind of start introducing and get that straight. And the first one is symmetry. So symmetry is this idea that if you take and you cut something right down the middle, you have the same number on the left side as you do on the right side. And so symmetry, you will see that the normal distribution is symmetric, kind of looks like a bell. And you can see that the green histogram that we have there kind of looks like a bell curve with regards to that. And then you'll see that we have this skewness. That's another math term for more data to one side or to the other. And so if we have the red histogram where the right tail is small and most of the data is to the left, they call that skewed to the right. And then you can see that where the left tail there is long in the data in the blue, the bottom one, we call that skewed to the left. So the idea of where the data is, especially where most of the data is really important. So you can see again on the green one, most of the data is congregated in the center. And you can see here, most of the data is on the small end in the red one. And most of the data here is on the big end for the blue one. And what I mean by small and large, it's the value of the categories that we have down there. The other thing we talk about is this idea of modal. And an example of a single point having the most data or a single category having the most data is called a unimodal. And you can see here, this one right in the center is the highest. Bimodal means there's two that are really being pretty high, and you can see that it's data here is congregated in this peak, and then there's data here and they're congregating in the second peak. And then we call that bimodal. We won't use this very often, and skewness we're not going to use that much, but symmetry is probably, if you think about these three concepts, that is by far the most important, and we're going to be using that quite a bit throughout this semester. So the last thing is we're going to introduce a couple other ways to display the data. This first way is sometimes it's nice to graph these things. And if you have a category, right, or a class, sometimes it's nice to know what's in the middle of the class, right? And so back in your algebra days, you calculated a midpoint of two numbers where you added them together and you divided it by 2. Same thing with the class midpoint. You just take the two numbers of extremes and you add them together and divide by 2. So in this case here, you could see these would be the midpoints with regard to that. And what we've done in the calculations is the 0 and the 1 and the 2, and so on and so forth. Another one is this frequency polynomial. And this is usually done if you wanted to do kind of it's basically a line graph. And basically what you're doing is you're taking each one of these frequencies and putting it into the midpoint of the class. And so 1/2, 1.5, 2.5. And you could see that the first point is 1.5, 9. Second point, or excuse me, 1/2, 9. Second point is 1.5 and 26. And we just basically connect the dots with the straight line. And that's what we call by a frequency polynomial. Not used very often with regards to this kind of data. We're going to be talking about something called a scatter plot when we get to chapter 4, which is much more useful than the frequency polynomial. Another thing that's sometimes done is called cumulative frequency. What does that mean? Well, cumulative frequency is this idea of taking the first value of frequency in the first class and you put it in the first one, which implies that you're adding it to the number 0. And then the second entry is this 9 plus 26, which gives us 35. The third entry is 35 plus 11, which gives you 46. And the fourth entry is 46 and 13, which gives you 59. And so you kind of zigzag the addition around. But to get the first number, if you think about no entry, it would be 0 plus 9 gives us the 9. If you think about the first entry being blank. And so when you get to the bottom, you should get to the total number of data points. In this case, this was 65. And so that's what you would end up with regards to that. So let me show you back on this. And if we wanted to calculate the cumulative frequency, how would you do that in an Excel spreadsheet? So the way I would do it is, again, the first number you just bring over. So that would be 3. Now remember that if I add all these up in the frequency column, that will tell us the total number of data points. And so if you remember, there were 40 statistics tests that were put into each one of these classes. And so the next one is the 3 plus the 6 would give us 9. So the way I would set that up, so then you could do the copy and paste, and it would be equal sign in that cell, and then you hit plus this cell, and you get 9. And you can see that if you wanted to copy and paste that down, it would do the calculations for you. And again, the first paste is the formula paste, and you can see the last entry always should be the same as the total number of data points. Again, cumulative frequency not used that much. Definitely frequency and relative frequency are used quite a bit more. This last thing is called an ogive, and this is this idea of plotting the x-coordinate is the upper class and the y-coordinate is the cubital frequency. And I want to be bluntly honest with you, class. I never heard of this before until we started using this book. And so not very commonplace with regards to that. But I wanted to introduce this to you. You will not be tested on this part for sure with regards to that. So that ends lectures for section 2.2. There's one part of section 2.3 that we're going to go over that I will do next, and then that'll end chapter 2.